Jane and Thomas own a sandwich business. They decide to price sandwiches individually each morning. At 3 p.m, any unsold sandwiches are reduced by 45%. Any sandwiches still unsold by 4:30 are reduced by a further 20%. Jane says, why not reduce by 65% at 4:30? It works out the same. Thomas disagrees with Jane. Using multipliers show that Jane is incorrect. Right, because the first one, all right, the original is 100%. So at 3 p.m, it's reduced by 45%, which means 100 take away 45 is 55%. So that means it's the first multiplier is 0.55. Like we did with the compound interest, you put a 0.55 in front of it. It's now reduced by a further 80%. So because it was so the original, again, if this is reduced by 80%, okay, the multiplier there becomes 0.80 because it's reduced by 20%. 100 take away 20% is 80. So then what you have to do is 0.55 times 0.8 comes up as 0.44. So because it's reduced, so that means the final cost, the multiplier of the final cost is 0.44, which means it's reduced by 56% and not 65%, because the original was 100 and it's now worth 44% of what it originally was. So 100 take away 44 is 56. So it's reduced by 56 and not 65. Part B. Write down and simplify two formulas in terms of P to calculate the reduced price of sandwiches at 3 p.m. and 4 p.m. Right, at 3 p.m, the formula, the full price, okay, or T, the price of a sandwich at 3 p.m, is the full price multiplied by, it's been reduced by 45%. So 100 take away 45 is 55. So T at 3 p.m. is equal to P times 0.55. Okay, at 4:30, all right, R, the price, would be P times 0.55, but then it's reduced by a further 20%. So 100 take away 20 is 80, so it's further reduced by 0.80. If I'm going to simplify it now, I know 0.55 times 0.80 is 0.44. So R is 0.44 times P. So multipliers, so T is equal to 0.55P and R is equal to 0.44P.